With the wafer doped, the next step is to create the gate oxide. The wafer is placed in the furnace to grow an oxide layer on the wafer. With the oxide layer in place, the wafer is patterned using lithography, which will be used to expose the source and drain areas of the substrate. Then the wafer is etched in buffer HF to expose the source and drain. Finally, the photoresist is removed and the wafer is ready for metal deposition. The purpose of this step is to ensure there's an insulating material covering the channel between the source and drain before the gate electrode metal is deposited. The first step is to grow the gate oxide in the furnace at 1050 degrees Celsius in an oxygen environment for 80 minutes. This creates a 90 nanometer thick oxide layer on the wafer. Then the same lithography process that was used for patterning the gate oxide is used to set the features needed to open the source and drain while keeping the gate covered. The main difference in this process is that the mask aligner is now needed to align the mask to the features left on the wafer from the previous step. With the wafer loaded in the mask aligner, the mask alignment cameras are swung into position above the mask alignment marks. The marks on the mask are clearly visible on the cameras. The cameras are focused onto the wafer to view the wafer features. The wafer marks come into view. The wafer is rotated and aligned vertically and horizontally using the micrometer gauges until the mask is in alignment. Then the wafer is moved up to the level of the mask to complete the final alignment. With the final alignment complete, the wafer is engaged to the mask to ensure proper exposure. Then the mask aligner is cycled into the exposed position. The wafer is post-baked and then developed before the hard bake, which sets up the patterns needed to open the source and drain contacts during etching. Buffered HF is used to etch away the gate oxide from the source and drain. Now the wafer is ready for metal deposition to create the electrical contacts of the MOSFET.